Let's go through our quick reminder of completing the square. We are doing this completing the square for our, remember that is one of the methods you can do to solve a quadratic. We don't use it a ton. It's only really nice when, for example, your leading coefficient of the y squared is a 1, and the coefficient on the linear term, the y to the first, is something even. If those things are not happening, this is not always the nicest method to use. But if those are happening and you're good at completing the square, it can kind of speed things up. And in today, kind of a requirement for getting through what we're getting through. But here's what had to happen. And what will happen today is to complete the square, you can only have y's on that side, no constants, no x's, no nothing. So all things that are not y would be moved to the right-hand side, which is done for us right now. And then we look at b, which is the number in front of y. And this is what you do. Half of that, and square it, and add it to both sides. Okay? When we square something, it always comes out positive, and so the result always gets added to both sides. Half of 4 is 2, squared is 4 again. And that is the number we are adding to both sides. If you do not remember completing the square, you might want to remind yourself that I'm not just adding the 4 because it was the number in front of y, right? I got it from taking half of that number and squaring it. Now, the reason we are doing that, and I would never really show this because it happens the same way every time, is the purpose of then factoring this. And if you notice, if I were to actually go the long route through factoring this, that I get the exact same thing in both of those parentheses. That's the whole point, is that then I can write it as one parentheses quantity squared. So where are these numbers going to come from? The same place every time. The first term is the square root, or whatever variable you're working with. So square root of y squared is y. The sign here will match the sign that was on b. So we had plus 4y. This will be a positive. If it had been minus whatever, this would be a subtraction, but ours is a positive. And then however you want to think of it, half of b, or the square root of c, which is the same number in this case, in all cases. So it would be y plus 2 quantity squared. On the other side, we will have x plus 7. We do this because I can then, using this method, solve for y by square rooting both sides. I have to remember my good algebra that when I square root, I get plus or minus. And then to solve for y, I would subtract 2. And we would be done. In all of our differential equations, our goal has been to get to the function whose derivative is handed to us at the beginning. And in all of that process, we are trying to get to a y equals at the end. Don't forget that that's really what we're looking for. And what I noticed, kind of like on our quizzes that I was working on, is that some of us are forgetting to label what the function is. And it's just some function like 2 plus or minus the square root of x plus 7. It really doesn't need to say y equals. And we're going to look at that again more as we head towards our AP exam. But that's a big thing, is you have to classify, clarify what is all of these things. You can't just have a derivative written without writing that it's the derivative, dy dx, or f prime, or somehow having everything labeled, marked, etc., all notations correct. So y equals on all your equations. Okay. All right, so we will see that show up again today, and we will utilize that. We'll show probably less work, hopefully, now that we remember how to do our completing the square. But adding to what we did yesterday for our differential equations. Same process, so that is not going to change. What you're going to notice is a little different today is we will not be doing any problems today that have initial conditions. So that step that we had yesterday where we plugged in the initial conditions and solved for the constant, that step will not be happening today because we are not given initial conditions. And so all of our answers will have a plus c in them somewhere holding the place of that constant. The process at the beginning, like those first couple steps where we separate our variables, one side for the y's, one side for the x's, we integrate both sides, that does not change. We skip the step where we sub in our initial conditions and move straight to the solving for y step at the very end. Okay? All right, on a problem like this, move my y to the other side, I would have to divide. So we'd be looking at 1 over the square root of y, multiply by the dx, integrate both sides. This was one I noticed a lot of mistakes on. Remember that a square root can be written as a half, but if it's a square root in the denominator, it's a negative a half, right? slow down as you are looking at something like that when you are thinking backwards through your power rule. Okay, so I'm supposed to find the antiderivative of y to the -1/2, and I was noticing a lot of times, especially on power rule problems specifically, that we are taking the derivative again instead of going backwards through the derivative process. So remember that in my power rule, I did subtract to get to -1/2, which means we would go the other way and add when we are finding its antiderivative. So I had some number here, I subtracted 1 and got a -1/2, or -1/2 plus 1 gives me a +1/2. And then again, slowing down, that 1/2 times some number gives me 1, or you can go the other way, 1 divided by 1/2 should have a coefficient of 2. A lot of mistakes on that. I think we just get going too quickly on that. Difference here is it's a 1, so again, I subtracted 1 to get to 1, or add 1, we get 2. 2 times something gives me 1, and that something would be 1/2. And I will always put the constant only on the x side because we can always move them all to the same side and it's still just some random constant. Eventually, I'm trying to get y by itself anyway, so why would I move it to the y side, right? So always put it on that x side. Today, the difference is we aren't going to know what it is. So we just move past that part, solve for y now. Okay, now there are two things going on by y that I need to get rid of before it is by itself. The 2 and the 1/2, this is where we have our algebra conversation. What do I get rid of first? The 2. Okay, so I can divide both sides by 2. Dividing by 2 is the same thing as multiplying by 1/2, right? The 1/2 times 2 is gone. Now, when I distribute that 1/2 through here, 1/2 times 1/2 is 1/4. And then 1/2 times c is c. That didn't trick anybody. It's just c still, right? That's never going to change. Y to the 1/2, how do I get rid of that? Square, right? You can rewrite it as a square, right? You don't need to. It doesn't matter as long as you remember algebraically how to get rid of that. I can always multiply a fraction exponent by its reciprocal, right? And I would do that to both sides. The 1/2 and the 2 are going to cancel on this side, and we get y equals 1/4 x squared plus c, quantity squared. Last algebra conversation before we move on to our next one. Can I now take that squared through there and say that it's 1/16 x to the 4th plus c? Please say no. No, right? If I have a binomial squared, you would have to write it twice in FOIL, right? We don't need to write it twice in FOIL. Just stop there. That would be our answer. Questions? Okay. Now, I just said that we can't distribute an exponent through. That parentheses on the last page. What about this one? Yeah, difference. No plus or minus, right? This is called a monomial. That one you give everything the exponent to. We saw one like this yesterday, so go ahead and work a little bit ahead of me on this one. Very similar to the one we saw yesterday. Again, careful as you are thinking backwards through your power rule on your antiderivatives. Okay, again, kind of speeding up our process. If I have y to the 2/3 and I move it to the left-hand side of our equation, I'm dividing by y to the 2/3, right? But instead of writing 1 over y to the 2/3, knowing where I'm going, what else could I write it as? -2/3, right? As we move it across, the exponent's going to look like it changes signs, and it really does because we're dividing by it instead of multiplying. And that is, again, going to force us to slow down and think about our power rule because we have side by side a positive exponent and a negative exponent, being cautious as we think backwards through that. I subtracted 1 from something and landed at -2/3. What was that something? One-third, right? add 1 to negative 2/3, we'd be at 1/3. And then slowing down and thinking about, okay, I'm taking this number times something, and I end up getting 1. What is that something? 3, right? 1/3 times 3. On the other side, I can take that 2/3 exponent, add 1 to it. It gives me the exponent on my x. 2/3 plus 1, or 3/3, would be 5/3. What's the coefficient if the exponent is 5/3? 3/5. Plus c, right? And then we're back to what we did on the last page, is get rid of the 3, get rid of the 1/3. So divide by 3 or multiply by 1/3. And distributing that 1/3 through, 1/3 times 3/5. What is that? 1/5. And as always, c is just c. Okay. And then opposite of raising to the 1/3, cubed, right? Solved for y. Questions? All right. This one is just really good algebra conversations for us to have, and then working in how to solve a quadratic. On this one, yesterday I said that when I move the y's over to the left-hand side, that I want to take as little as possible, because eventually I want y all by itself, right? So when I go to multiply by that to get y over there, do I have to take the 1 with it? Can I just take the y to the other side? I can't just take the y, right? Remember that addition and subtraction is like the strongest bond in math. You cannot just like break off part of it. It's like in algebra 2 or something, if I had x plus 2 over x plus 4, I can't just like cross off the x's and say that that's 1/2, right? You can't break something off of the plus or minus. So yes, we have to take the 1 with us. So I can get that out of the denominator, multiply by that dx. So then I'm looking at this, and this is where our lazy notation can kind of catch us, because when I write it like this, it kind of looks like, can't I just subtract 1 to the other side? It really is in parentheses, because it is 1 plus y times dy. And if I wanted to move either of these separately, I would first have to distribute the dy, which then I wouldn't want to move them because they would then both have a y attached to them, right? So just be cautious with sometimes we get a little lazy with our notation there. It really is 1 plus y in parentheses there. All right, so then we would integrate both sides. But we can integrate each of those separately, right? What is the antiderivative of 1 with respect to y? Good. And then our 1/2 y squared. Okay. This problem right here is the first time that we see the need for our warm-up. We do need to now remember how to complete the square, because ultimately I want this to say y equals at the end. And so the method we use for that is to complete the square. Now, one thing you'll notice, when we were completing the square earlier, we had a leading coefficient of 1. And it is so much easier for you to do that than to leave any other leading coefficient. So do that. Start by manipulating this equation so that our leading coefficient is 1. What can I do? Multiply by 2, right? So before I do any process for completing the square, I'm going to take both sides of this equation and multiply by 2 so that I have a leading coefficient of 1. Okay, then we go through our process of completing the square. So take half of b, Half of 2 is 1. Squared is 1. Add that to both sides. I do that so that it factors the same way every time. It'll factor into y, that sign, half of b, y plus 1 quantity squared. On the right-hand side, kind of looks like I forget that I was supposed to add 1 to both sides, but if it's a constant plus 1, it's still just a constant, right? So it's going to say x squared plus c. Square root both sides, continuing to get y by itself here. Whoa. Being a good algebra student and remembering my plus or minus when I square root, and solving for y. Yesterday we had a conversation about when we square rooted that we did need to pick whether it should be the positive or negative version of it. But because we don't have an initial condition, this is representing all functions whose derivative are given at the beginning, which is why we just have a token constant in there. So we can't distinguish between the plus or minus because some of those functions would be a plus and some of those functions would be a minus. Questions? All right. This one actually is a pretty mild one. We saw already in our assignment some that had trig that were actually a little bit more complex than this one, but it doesn't change our process. We still separate our variables. So move your y to the left-hand side, x's to the right-hand side. Once we've got that separation, integrate both sides. Okay, always careful with that positive versus negative, antiderivative of cosine, positive or negative? Positive. Plus c. Solve for y. And square root. Plus or minus, because we don't have any way to narrow it down. Questions? Okay. The last one I'm going to get you started on, and then you guys are going to work together to finish this one. Just helping with the separation of our variables on this. If you notice, the square root of 1 minus 3x squared has an x in it, so eventually I'm going to move that to the right-hand side. Move the dx to the right-hand side. There's nothing to move to the left-hand side as far as dy. This is multiplication, right? So as I move that to the other side, I'm going to end up dividing by it. Multiply by the dx. And left with dy on the left-hand side. I know we already saw this, but just a reminder, what is the integral of dy? Y. Okay, and then you guys are up. Integrate the right-hand side. You are welcome to work with your table partner. You may have to have a discussion about some techniques we've used over the last 2 weeks. What technique are we using? U substitution. What are you letting U equal? All right, let's remind ourselves of U substitution rules here. I do need to find the derivative of U and solve for dx. One of the things I noticed is that sometimes we lost the things going on around whatever we let U equal. For example, in this one, that we would replace it into the denominator and forget that there was a square root around it. So just be cautious as you are doing this, that we aren't losing those types of things. The x's cross off, which is a good indication that we've picked the right technique, because now I'm down to a function of U. I'm going to slide that negative 1/6 out front. I am looking at 1 over the square root of U. I'm going to pick to write that as a negative 1/2 exponent, because it's easier to think through my antiderivative that way. Again, negative because it came from our denominator, 1/2 because of the radical. So again, being cautious of all those little details as we are manipulating these things. My antiderivative, I would have been at 1/2 to subtract 1 to get to negative 1/2. 1/2 times 2 gives me 1. And then another common thing I was noticing is sometimes we forgot to sub U back into the problem. Remember that that's just holding the place of something. It is holding the place of that function right there. So at the end, we're not done until we've replaced U with the expression 1 minus 3x squared. So negative 1/6 times 2 would be negative 1/3. I'll replace U, and actually I could still raise it to the 1/2 or change it back into a square root. It's the same thing. And this really should say y equals, right? That's what the whole goal was, to get to a function that says y equals at the end. So now we've kind of bringing in, we've separated our variables, doing those differential equations by separation of variables, but also needing to utilize things like U substitution, completing the square, lots of different techniques happening. Any questions? All right, you guys are getting a worksheet today. There really isn't room to write on the worksheet, but you can only do 1 through 10. We have not, well, there's a couple that you probably could figure out on the bottom there, but that's going to be more our topic of conversation tomorrow. But 1 through 10 for tomorrow, please.